Section 3.8 is derivatives of inverse trig functions. So an inverse function, if f is differentiable at every point on an interval, and if f prime of x is never 0 on the interval, then f has an inverse, and f inverse is differentiable at every point on the interval f of I. So here's our rule. If f inverse of A is B, so if you're given an inverse, the inverse function slope relationship relates the derivatives by this equation. F inverse prime of A is 1 over f prime of B. So make sure you write this down. It's really useful, it's very important, and it'll help us get through some of these derivatives of inverses. So let's look at a few to start with. First of all is the derivative of arc sine, or sine inverse. If u is differentiable with absolute value of u less than 1, because we know that we can't have a sine function greater than 1, we apply the chain rule to get this rule. Now, this is the rule that we're looking at. The derivative, I don't know why my pencil jumps like that. The derivative of sine inverse of a function u is, my goodness, there we go, is 1 over the square root of 1 minus u squared times du dx. That's if u is a function other than just x. We're using our chain rule here. And again, u having to be less than 1. Let's look at where this came from. I don't know how much of this you did last year. If this is review, that's fine. If not, we'll work this out together. So let's look at the function y equals sine inverse of x. And if I wanted to figure out the derivative of this on my own, this is what I would do. First of all, I would rewrite this as an implicit function. The sine of y equals x. Remember, in this format, x is our trig ratio and y is our angle measure. So if I rewrite it this way, I now have a more function that I'm used to. The sine of an angle equals a ratio. Well, this I can do the derivative of with no problem. So again, differentiating both sides with respect to x, the derivative of sine y is cos y times y prime, my chain rule, because I'm doing d dx of both sides, and that equals 1. The derivative of x with respect to x is 1. So now if I solve for this, y prime is 1 over the cos of y. My problem here is that I need to now put this in terms of x. So let's go back to the beginning and look at a right triangle. If I start that the sine of y equals x, y therefore is an angle measure. If the sine of y is x, or x over 1, that's opposite over hypotenuse, so I can label my triangle this way, which, using Pythagorean to find my missing piece, I find out that my question mark is the square root of 1 minus x squared. So again, using this same triangle, the cosine of y is adjacent over hypotenuse, or 1 over the square root of 1 minus x squared. So that's where this formula comes from. You have two choices. You can memorize that the derivative of sine inverse is 1 over the square root of 1 minus x squared, or you can go through this process every single time. Again, it's up to you. So let's take an example using this, where here we have our function within a function. We are going to need chain rule. So using my rule, I'm going to say that y is this and u in our definition is our 8x squared. So dy dx is 1 over the square root of 1 minus our function squared times the derivative of that function. Simple chain rule. Cleaning things up, 8x squared is 64x to the fourth, and the derivative of 8x squared is 16x. And then just simplifying it a bit further to make it nice and neat. Okay, so that's an example of how we would use the derivative of arcsine. Let's look at another one, arctan. Again, we could do the same thing that we did with our sine function, rewriting it and solving it by doing it implicitly and using a right triangle, but this is our formula. Okay, and secant is the other one that we need to use, and there is our formula for secant. Now we've done sine, tangent, and secant, and hopefully you've paused several times to write all of this down. So what do we do? Well, I think first we're going to do an example with secant. So secant inverse of 3x minus 4, using our formula and understanding that our inside function is 3x minus 4. The absolute value of 3x minus 4 times the square root of our function squared minus 1 times the derivative of this, and the whole thing becomes 3 over the absolute value of 3x minus 4 times our derivative. And I'm not sure why that didn't go all the way out. That should be extended, because what they've done under the radical is they've FOILed out your 3x minus 4 to get 9x squared minus 24x plus 16, and then they've subtracted the 1 to get 15. That should all be under our radical symbol. Okay, so again, we've got sine inverse now, we've got tan inverse, and we've got secant inverse. So what am I going to do about my other three trig functions? Well, let's take a look. Cos inverse, which we haven't done, is pi over 2 minus sine inverse x. These are our cofunction identities. Cosine and sine are the same on a graph. They're offset by a shift to the right. Pi over 2, the same thing with cotan and tan, and cosecant and secant. So we can write all of these functions using our cofunction identities. If you want to use your calculator, secant inverse is cos inverse of 1 over x. So there is no secant inverse button on your calculator. Cotan, we're going to use our cofunction, and cosecant, we're going to use our reciprocal again. So if you need to plug any of these into a calculator, this is what you're going to use. Okay, and using those things, we should have a pretty good idea of being able to do any function that we want, calculator or written derivatives. So let's try one. Cotan inverse of x squared. Now cotan is not one that we had, so we're going to rewrite this as pi over 2 minus tan inverse of x squared. Again, u here is x squared. This is our inside function we're dealing with. So taking the derivative, we get 0 minus 1 over, using our tan inverse formula, and then the derivative of x squared. So we have negative 1 over 1 plus x to the fourth times 2x, and we can rewrite it like this. Look what happens to our pi over 2. It becomes a 0. So really what we're saying is that the derivative of cotan, the derivative, let me write it this way, of cotan inverse of x squared is really the opposite of the derivative of tan inverse of x squared. And the same would hold true if we go back a few slides. Look here. So the derivative of cos inverse is the opposite of the derivative of sine inverse, because when we derivate, all of these become 0. The derivative of cotan is the opposite, and the derivative of cosecant is the opposite. So if you memorize the derivatives of your sine, tangent, and secant, then by putting a negative sign in front, we will get cosine inverse, cotan inverse, and cosecant inverse. Okay. Please, if you have questions or if you haven't seen this before, let me know. That's back to the slide we finished up on. And that's it.